안녕하세요. My name is Awa, and today I'm talking about variance of proof of stake and the importance of building strong validators and delegator sets. So a little bit about myself. I am one of the founders of Cryptium Labs, and my main areas of research are currently consensus algorithms, proof of stake mechanisms, and the security around these protocols. As they begin to Cryptium Labs is a network agnostic validator. We have been validating for Tesla since July, and we'll be upcoming validating for any kind of reasonable proof of stake protocols. By reasonable, we basically mean two things. The first one is that they have to improve public blockchains, and the second one is that they have to rely on a kind of a protocol staking mechanism that actually has something at stake. So, however, we believe that validators should not focus on only providing the validations as service, but rather that they are in the perfect position to contribute to all these ecosystems in much better ways. So for example, by development and research, we mean proposing future protocol upgrades, developing tools that either for other validators to use or for application developers to build on top of these frameworks. Another thing is that we're really focusing on, or we encourage other validators to do, is to developing the community. Isn't basically, because validators have to understand the protocols from inside out anyways, it should be in our responsibility to basically distill this knowledge and then provide it either in written way or in spoken way for anyone to understand basically how each of these protocols work, no matter what background they come with or no matter what language they speak. Because believe it or not, most of the token holders of all these networks are pretty diverse. So today, before starting with proof of stake, I'd like to clarify on some basic concepts. So up until now, I'm pretty sure we heard of proof of work, proof of stake being defined as consensus algorithms and so on. But honestly, it's probably more correct to just split those two concepts. So first of all, consensus algorithm is not equal to proof of something. But rather, consensus algorithms should be defined as mechanisms that enable peers to agree on a specific set or state of values, and proof of something are mechanisms that determine what peers are eligible to participate in consensus, or rather, in other words, what kind of requirements a validating node need to satisfy in order to be eligible to produce blocks. So two families of well-known consensus algorithms. Nakamoto consensus, first used by Bitcoin, is basically used by any public blockchain we have, almost anyone we have seen now in this public. In Nakamoto consensus, the valid chain is the one that has the largest pool of work, or largest or heaviest, or largest is the one that is canonical. Whereas in the new family that is going to be increasingly important, that we're going to see hopefully soon come into production, is the family of Byzantine fault-tolerant consensus, or BFT in short. In BFT, consensus algorithms, the chain that contains the latest block that has two-thirds or more of the validator set signature is the right one. Two families of proof of something mechanisms. There are proof of work, of course. In proof of work, validating nodes in order to participate in consensus, they need to compete with other nodes in solving a cryptographic puzzle. Or try to find the knowns before other ones, and then that one gets to produce the next block. In proof of stake, however, it depends on case by case, but most of the cases, it requires that the validating node allocates an amount of wealth or amount of value as a collateral, which later on they can actually lose in case they deviate from the protocol. So ironically, with the introduction of proof of stake, with the family of proof of stake mechanisms, there was an issue that started to appear, which is called the nothing at stake problem. The nothing at stake problem, in short, it means that any validating node can actually cause and maintain forks at no cost. And it is an increasing issue because it is an issue that's present in both academic and the commercialized projects. In particular, there's one variant that's called Delegated proof of stake, used by protocols like Pictures and EOS that suffers from it. So the major assumption that Delegated proof of stake makes is the fact that if a block producer, the validator, the terminology for a validator in that case, misbehaves, it would not get voted in the upcoming rounds. So slowly it will run low enough so we won't be able to produce blocks anymore. However, is that a fair assumption to make? Because it relies on, first of all, that the token holders actually have the tools to detect that a block producer is misbehaving, and secondly, that actually incentivized to act upon it. Just some food for thought. I'm not sure. I don't really know all the answers right now. So why would you, as a app developer, care about all the security consensus algorithms and proof of something mechanisms? I would say, if you happen to choose a platform that suffers from this kind of issues, you will actually be providing a maybe bad experience to your end users. For example, if you happen to choose a platform that suffers from nothing as state problem, you're actually exposing the funds of your users to long-range attacks. So let's say a validated node can actually trick light clients into believing one state over others, which in implication can cause the end users to lose funds. I believe that most app developers here would not want to offer that kind of experience. So just be mindful of the features you're actually choosing, depending on what platform you choose to build on. So some variants of proof of stake. They're actually more than these ones. I chose them because after looking at this space, it seems that these four are the most interesting ones at this point. The first one is liquid proof of stake, which is used in Tezos. Bonded proof of stake is used by the Cosmos Hub or the Iris network or any other networks that we built on the Cosmos SDK. Nominated proof of stake will be suggested by Polkadot, and then Casper will be hopefully eventually implemented on Ethereum. One way of classifying them is by looking at which kind of consensus mechanism they couple with. So let's say liquid proof of stake is characterized by going with Nakamoto consensus or the heaviest chain consensus. Whereas bonded proof of stake is kind of novel because they introduce test a new family of consensus mechanisms, which is the BFT consensus, and in particular Tenemy consensus, which is a variant of BFT. And then nominated proof of stake and Casper will try something more novel, which is a combination or a hybrid consensus between Nakamoto and BFT consensus, which gives us a good time to talk about finality gadgets. I'm pretty sure you have heard about finality gadget from Vitalik, or I think briefly this morning, Al has been talking about probably Polkadot's finality gadget. It's a pretty interesting topic. Finality gadgets are basically either an overlay on an existing chain or an independent chain whose purpose is to provide finality. And this is important because maybe you choose that your underlying chain is relying on Nakamoto consensus because you do not want to sacrifice liveness for safety. Or maybe you have a legacy chain like Ethereum that is relying on proof of work and you want to transition to proof of stake. So an answer to that is basically finality gadgets. They can be either relying on the existing BFT family consensus, it can be a separate chain, it can be an overlay on an existing chain. It's just a way of providing finality. So looking deep into two variants, the reason why I chose these two, even though there are more, is because these two are currently more established. So let's say LPOS has actually been in production since June this year. And then VPOS is now releasing the latest testnets. Hopefully, most of the parameters will not change too much. But it makes it easy to compare. The other variants, the issue with them is that right now they still yet to be implemented. Even some specifications are out, but it may actually change as soon as they try it out with the validator sets. Okay, so LPOS. In LPOS, LPOS relies on the Nakamoto consensus. In order to become a validator on Tezos, you have to own at least 10,000 XTZ, which later on has to allocate a cell block. And that's the requirement to participate in consensus. How do you earn baking slots or endorsement slots? You earn them via a pseudorandom system. It's more like a lottery-like system where the more staking balance you have, the higher chances you have to get more validating endorsement slots. What is the stake is the baker self-bond, the rewards and the fees of whatever blocks are sent to them. And the slashing conditions here, they actually seem pretty non-harsh, but in reality a lot harsher. So it says here is for a double signed block, double baking in Tezos, everything is called baking and bakers. Is 512 XTZ per baking slot and 64 per double endorsed slot. But careful, this actually means that, let's say, over a cycle is how Tezos measures time. Over cycle, let's say you have 100 slots in total, right? And then in the middle, you commit a safety fault, and then somebody denounces you. So all those slots until the middle you actually have to pay for all the security deposit that you put on as collateral for all the slots until the middle. And then it doesn't actually stop here. And now you actually have to stop validating, because otherwise you have the other half that can actually be lost again. So in the best case, if you commit a safety fault, you will lose up to all the slots, plus at least the rewards that you will stop producing because you have to stop the activity of your validating node. It's actually harsher than we initially thought. The rewards are 16 XTZ per big block plus the transaction fees, and then per endorsements it can be over either 1 or 2, depending on the priority that it was produced. So this results in an overall annual inflation of 5.51% of our total supply in the most optimistic scenario. Where the time between blocks is 1 minute, and where everybody the life consumption is like basically 100%. And then again, the Baker set is recalculated every cycle. It's 2 to 3 natural days. So Cosmos, BPLS. In BPLS, it relies on the dynamic consensus, a variant of BFT consensus. It's 2/3. And in order to become a validating node, you have to be part of the top 100 by economic stake. By economic stake means that you have to run the top 100 by your sub 1 plus your delegation. And then you get assigned slots with a system of weighted round robin, which in practice is very similar to the lottery-like system. We can actually influence by having higher total staking balance, let's say. But careful, the difference here with LPOS is that delegations are also stake. In Tezos, delegations are not at stake. It's only self-bond gets affected. So the maximum when committing safety faults, the maximum you can lose is the total of self-bond. Whereas in Cosmos, the maximum is your self-bond plus all the delegation. And then the slashing conditions are also a little more extreme right now, at least. It's for double signing, you lose 50% of the total staking balance. 50% means that if I have overall 1 million atoms in my self-bond plus delegation, 50% of that goes away if I double sign. So pretty exciting about that. Another thing is that they punish for lightness directly, and that is related to BFT. Right on Cosmos, if the network doesn't reach consensus in the latest block, it would just wait until enough votes actually been committed. So that's why lightness has to be somehow penalized, because otherwise the network will hold too often, and it's probably not a very usable network if it holds too much. The rewards are similar to validation rewards plus the fees. Inflation seems to tend to be a bit higher, so something around 7% in the lower bracket, 20% probably in notion of higher risk, higher rewards. And then the validator set gets recalculated at the end of every block. So here's an example of proof of stake in action. Because it's pretty new, we don't really know, slashing, do people actually lose money? But yes, you actually lose money if you cause faults. And then I don't know if you can see it over there, but basically here I'm showing 2 very recent occurrences of validating nodes on Tezos, where they got slashed for double signing blocks. And one of them lost over, I think, almost 30,000 in something around 48 hours, and the other one lost around 30,000 in less than 12 hours. So yeah, this is real. You really lose money. If you're thinking of becoming a validator, consider this risk. Try to really invest in the security features of your infrastructure. So, this is actually the part that's most important. If you have to go away with one learning, I would say this is probably the most relevant part. So with introduction proof of stake protocols, it didn't really exist before with proof of work networks. We introduced 2 major stakeholders to these networks, which are validators. Validators are either token holders or nodes that acquire the validating rights one way or another, and then participate directly in consensus. And delegators are token holders who still want to get part of the rewards, but they don't want to, for whatever reason, they don't want to operate the validating node themselves, so they delegate those rights to the validators. And generally, in all these variants, it's hodling, so like keeping the funds and not doing anything with it, is economically discouraged because the inflation or like the rewards are only assigned to validating nodes or assigned to the delegators, either directly or indirectly, depending on the protocol. Another feature that these platforms are trying to introduce is what they call on-chain governance. So they actually choose to kind of give away more power to the future of these protocols, the future evolution of these protocols to the token holders or to the validators. And it basically means that if you validate a node in Tezos, let's say, you can vote for future protocol upgrades for one or another. You can also suggest ones. And in the case of Cosmos, even the delegator can override the vote of the validator. And this is the takeaway I was mentioning before. I think that protocol developers are not, designers and developers, they're not paying too much attention to this. But in reality, the security and the centralization of all these protocols relies 100% on the decisions that token holders make. So let's say, what is the point of decentralization if 75% of the validating nodes on my network are run on Amazon cloud instances? Because that's really not secure, because maybe tomorrow Amazon decides you cannot run validating nodes on our instance anymore, so 75% of your network goes down. That doesn't sound right, right? So either way you can do is, either you can, first of all, I encourage you to become validating node yourself, and you can contribute to the validator set by trying to pay attention to security features, trying to choose a geographical area that is uncommon, generally running your own infrastructure, maintaining it. If you're a delegator also, you can incentivize validators that focus on those security features by delegating to them, as opposed to other ones that may be running on cloud instances. But also be mindful of the general distribution of the network. We've probably, seems that naturally these networks tend to, let's say, top 10 own 70% of the 90% of the total staking balance, but this is actually not a scenario that is desirable due to security and decentralization, if that's what you're trying to achieve. So try to delegate to people where you achieve, try to diversify first the delegation, and try to achieve this balance, staking balance, across all the validator sets. So I'll be around actually, so if you have any questions around proof of stake or something like that, just let me know. Otherwise, you can reach out to us via email or via social media, and also I will post the slides on our GitHub. That's where I'll have. I also mentioned about community development. We have a blog on the Medium, which is in multi-language actually. Right now we're supporting Chinese and Spanish and English, of course, where we explain basically every single thing about each of these protocols. And then you can grab them. It assumes that you have no background knowledge, and it assumes that you might even be new to blockchain, but still try to let you understand whatever all the implications and the lines of these technologies. I think that was it for me. I have time for questions. One? Okay, I think I have time for one question.
Thank you for a great talk. Can you tell a bit about who should run a validator? Is this something you should do from out of your bedroom, or what's the requirements? What kind of validator do you run?
Okay, that's a good question. I don't think there's one answer to that question, but it depends on, I would say, the risks and rewards, right? So in the most ideal scenario, you would run, I think right now, from my point of view, you would run a physical hardware that is owned by yourself, maintained by yourself, in a maybe a data center that maybe you own. That's even better. So I would say that is probably the best. However, there are networks that even encourage the single person that has a computer at home to run a node. It's just generally in practice that's not very good because you have to secure Lightness, otherwise you lose rewards, or otherwise you get directly penalized. It's hard to say. I really hope that it evolves in a way that we can actually run nodes in a purely decentralized way. We can even run nodes at mobile devices or something. But right now, I think if you really care about security, which you should, because otherwise it translates to direct loss of money, I would say data center, physical hardware, and then try to use HSMs, especially when they support, or they'll even write your own HSM support to avoid safety faults or something like that. Right? Any other questions? Okay, otherwise just catch me around here. Thank you very much.